2012 was an extremely prolific year for the data and analytics space. So many new products came into existence that year, Snowflake, Amazon Redshift, ThoughtSpot, but probably the most exciting and impactful creation was of Apache Parquet file format. Why do I say this was most impactful? Is because we expect that 80% of structured data, especially in the cloud, is going to exist in the Parquet file format in the next few years. Who better to talk about Apache Parquet file format than the founders, Julien and Nong and Nong. I am honored to be sitting here in Berkeley, California, to talk to the two founders, and I'm going to hand over to Julien. Can you please introduce yourself?
Hi, I'm Julien and So I'm currently chief architect at Astronomer. And so in 2012, I was at Twitter after a stint at Yahoo for a few years, where I worked with Hadoop in particular. And we're going to talk about our collaboration. And after that, did a few things, work at Dremio, WeWork, and more recently also work on the open lineage format. And I'm at Astronomer, working on orchestration, data observability, and such things.
Very nice. And Nong?
Yeah, it's great to be here. In 2012, I had been at Cloudera for a few years at that point when we got started, working a lot of the Hadoop ecosystem, open source projects, largely Impala at the time. After Cloudera, I was at Databricks doing sort of similar architecture work for Spark 2 and some of those kind of activities. And then just over 6 years ago, started my own company, Okera, who are centered around problems in the same ecosystem, but focused around security, privacy, access management, those kind of things.
Oh, very nice. Let's dive back to 2012. So Nong, I'll start with you. In 2012, what was the problem that you were trying to solve when you came up with this Parquet idea? And were there not right tools and technologies available for you to use at that time?
Sure. Yeah, I think 2012 and around that era is when a lot of us were thinking about, I'll call it Hadoop v2, right? So if we think about things that are moving just past MapReduce as the core technologies and the surrounding things that help it, what about doing kind of the next phase? And I would think about Impala, Spark, Presto, as kind of the compute frameworks that are part of that overall thing. And I think Parquet is a core technology as part of that. So I think for all of us, we were trying to say, okay, split storage and compute, very elastic infrastructure, reducing costs, all those kind of good things. What are the gaps we need to make this more enterprise suitable, right? For efficiency, cost, performance, storage, so on and so forth. So I think a lot of us in the ecosystem were thinking about that. And from some of the work we were looking at for Impala, really focused on query performance.
Yeah.
Right? How do we make SQL run fast as possible on this? We felt that we needed a fundamental innovation on the storage technology. That was the bottleneck we had identified.
I see. And you were at Twitter.
Yeah.
So you guys had not met at that point in time?
No, we had not. So at Twitter, we had a Hadoop cluster.
I see.
And
he was a big deal in Apache, so I knew who he was.
I had been at Twitter. I was working on Pig in particular. I was working on the processing tools, and so through the years, I'd been a committer, a PMC member, and I did a PMC chair for a year for the Apache Pig project, which is a bit less known now. But now, basically, Apache Spark took over what people are using Apache Pig for. So yeah, I'd done a little bit of Apache stuff.
I see.
And so we had Hadoop, where we were running Pig or Scalding jobs on top of, and so we could have a lot of data and have a lot of throughput, but it was high latency for a query, right? You would launch your job and use a MapReduce days, you'd get a coffee, and then you would see the result later.
Like the timeline or something, if you wanted to see that.
Yeah, so there's a lot of things that were happening on the Hadoop cluster, and a lot of data. This was hundreds of terabytes coming every hour on the cluster. And on the other hand, we had Vertica, and so Vertica is this MPP, distributed query engine, like a warehouse, and you would have much lower latency queries. But it would not scale as much, right? We couldn't put all the data into Vertica, right? So there was always this friction of, we only have a subset of the data, either not all the tables or a shorter time frame, and it was a big limitation. So Vertica is a columnar database. And so basically I was looking at how do I make Hadoop a little bit more like Vertica, from the bottom up, from the storage layer.
Yeah.
And I had read the Dremel paper when I was at Yahoo, building platform on top of Hadoop as well. And so, that's how I started prototyping something in my shuttle ride. At the time I was commuting from the South Bay to San Francisco, and I don't get motion sickness. So I was that was my 20% time of back and forth on trying to implement this algorithm in the Dremel paper,
right,
and doing something.
So you both started your own projects. At that point in time, there was no overlap, right? So you were just working independently.
Yeah.
So you were, and the problem you were trying to solve was storage and efficiency. So when did you both meet and decide to collaborate and join forces?
So I think on my end, I was interested in making this happen, but if you do a new files format for Hadoop, right, you need to integrate in all the things that go around it. So I didn't want to do something that was proprietary to Twitter.
Right.
So I started tweeting about it. At Twitter, everybody tweets.
Yeah.
And there were some connections, right? My manager at the time had worked at Cloudera before. And so Todd Lipcon was one of the architects. Architect of Kudu. Kudu didn't exist yet at the time.
Right.
But he worked on the MapReduce a lot, like optimization and a lot of those things. Connected us because Todd knew that Nong and Marcel were working on a columnar file format to make Impala faster.
Right.
And that connected the dots, right? And I was working on the JVM stack, right, more in the Hadoop world.
Right.
And they were building native code query engine. And so there was a great collaboration, right? From my perspective, I was getting all the use case from the actual performance query engine coming in. And from their perspective, I think I was bringing all the compatibility with all the Hadoop ecosystem. So there was a great collaboration. I think that made Parquet a lot stronger than if it had been done by only one entity.
So I've heard there are two components of how you both came together. One was what you just explained, the technology, and the other one is food.
Yeah. They just wanted to freeload on the cafeteria, right?
I've heard Twitter had better food than Cloudera, and then you and Marcel would go over to freeload.
To freeload, yeah. For Twitter had amazing food, and we were working in the FIDI, so just a couple of BART stops away. So we would meet up together to work on some of these ideas. But I think this is how you see a lot of technologies being built, right? A lot of people tend to get to the same spot at the same time independently, right? This is a pattern I think you see in inventing new things, building new things. So I think we all reached a point where the current Hadoop file formats, the ways we're doing things, just aren't going to be what takes us to the next step. And unfortunately, and this is a great thing about the Hadoop ecosystem, certainly at the time, a lot of ways to connect people who are just working on shared problems. That's how we got started.
Who came up with the name?
Well, Julien had previously named the project after himself.
That's not true. My side of the project, I had called it Red Elm, which is an anagram for Dremel. It's almost an anagram for my last name, but I was looking for an anagram for Dremel because it was based on the Dremel paper from Google. And I think Emerald was already taken by another project. So I took Red Elm. And Twitter tends to name all projects after birds, and birds live in trees. So it felt like a good name. But that name was very the whole of Dremel or something, right? And then when we started collaborating, we were like, okay, we're going to focus that project on the file format, right? And so we need a name just for that. So we built a spreadsheet and proposed a bunch of names, and we voted for them. And I remember that Parquet was proposed by Marcel, who was the other co-founder of the project.
I remember the spreadsheets. We did many turns on it.
Yeah, trying to find the spreadsheet.
Did you save that spreadsheet?
I think it stayed in my Twitter, Google Doc account, and it's lost, unfortunately. But yeah, we had some names in this. Like it could. There are other. Sorry. There's a list somewhere of the names that could have been. So Parquet was a good name.
Yeah, no, Parquet is great name. Except some people call it Parquet, which is a bit annoying. But Parquet is a great name. So yeah. However, there was already a file format, if I'm not mistaken, ORC, which was also columnar, which was just starting. Is that right? Nong, do you remember? Like, why not use ORC and why Parquet?
Yeah, so if I were to give a brief history at the time, so Hive had a columnar format for a long time. It was called RC file.
RC file, yes. Correct.
And it had some of the overall goals, right, performance, etc. But the file format wasn't, I would say, broadly adopted and probably didn't hit the goals that they were thinking about. Similarly, at a time, Doug Cutting, maybe the father of the Hadoop ecosystem, was looking at how to do this sort of as a maybe extension to the Abro project, an idea called Trevny, also an anagram. But that was also very early on, right? Kind of early days in thinking through this. And as we were looking at it, we wanted, it's a lot of effort to roll out a file format.
Oh my God, yes. Yeah.
So it's not a great thing to kind of like try and not get everything right and have to redo it and all those kind of things. So we were looking at it sort of from a grounds up, what's the best we can do? And that's how we came up with a lot of our ideas. ORC, like optimized RC or maybe some other genesis for their name, was probably born around the same time, right? I think there would be high overlap in our genesis history with similar goals. I think for us, we really focused on ecosystem compatibility. Right? The file format is core to all of these projects, right? And that was always been our focus and emphasis. I think Orc in particular, probably from their heritage, more Hive centric at the start. So we kind of similar goals, but pursue different strategies.
Yeah, from what I remember, RC didn't exist when we started. So I think it's those things like people work on it for a while, and when it's good enough, they start talking about it, right? So it's kind of, I think there was high overlap in how it happened, right? And it just proved that there was a need for such a columnar format, right? Different people saw it.
At what point, Julien, did you decide, both of you, that this is a much bigger effort and we should bring in Apache licensing and a community, open source it? How did that come about?
I think from the beginning, right, we wanted this thing to be not like a Twitter project or a Cloudera project, but really making a shared thing. So when we first started collaborating, we set up like a new org on GitHub, and there was like a Parquet org on GitHub, and it was just Parquet, right? It was not branded by any side, and the goal was really to be really open. Look, it's going to be a community effort. We're going to build it together. And it's like in open source, there's a little bit of, once you start using it and contributing to it, you become a stakeholder. You have some ownership to it, and it's really about building this community where people, once they start joining, they realize they actually have an influence on the decision making, right? And their input is valuable. And so other companies started joining, right? Like Criteo, which is this ad optimization company in Europe. They built the Hive integration early on, and they started joining. Later on, Netflix joined and made Parquet better, integration with Hive better, and like with Presto better. And so it started really growing from there. And so moving to the Apache Foundation was a no-brainer in my opinion, right? It's the next step in proving, look, the license is never going to change. It's never going to be owned by anybody, right? It's like a thing that we all own collectively. I think it's really important to the success of the project.
No, absolutely. So Julien, I'm very curious to see how you were reading Dremel paper thanks to not getting motion sickness on your BART trip or Caltrain.
It was a shuttle.
Shuttle, I see. Okay, so coming into San Francisco, but I'm sure there were like some gaps that needed to be, like some additional work that needed to be done. What was the delta that was missing in Dremel that needed to be done?
So the Dremel paper, so there are two main contributions in the Dremel paper. There's like the query engine and the kind of physical layout to do it, and this format to turn nested data structures into a columnar representation. So which is exactly the algorithm we use in Parquet to turn a nested data structure in columns, but it doesn't say anything, and actually in practice it doesn't do anything about encodings and efficiently encoding and compressing those columns. So there's a lot of the work we did was and like we collaborated on, and like
I see.
Todd Lipcon early on contributed some of the encoding, and we looked at different paper, other research paper, like there's great papers by Daniel Lemire that talks about encoding integers efficiently, and different things like that to how do we build all those encodings? And then, so a lot of the requirement came from the Impala team, right? Because the goal is you want a good trade-off in compression and being able to decompress it very fast, right? That's the advantage of, and even simple things like run length encoding, or things like that.
So, Nong, any thoughts on this?
Yeah, sure. I mean, there's certainly a lot of prior art in columnar storage formats, right? So I think even from the early days, if you're just doing it, there's kind of a set of things we all understand. Then I would say there's sort of the PAX contribution, which is how do you take a very, very large data set and split it out into sort of first horizontally by a number of rows and then columns inside. So Parquet took that as row groups. As Julian's saying, Dremel helped us understand how do you go for nested data, which if you go into the details, that's just a very non-obvious solution, right? What they shared and what Parquet supports is, I would say, non-intuitive. It's very efficient, but that was sort of the main contribution that we pulled from there. And then if you go into the details, as Julian's saying, on encoding, CPU performance, all these kind of things are sort of the very nitty-gritty details that matter a ton. But you have to go figure out all those things.
Every software project ever has multiple versions, version 2, version 3. But Parquet, it seems like you got it mostly right, because I've never seen version 2. I'm just curious, are there like pieces of Parquet that went missing, or do you feel there are things that you should have added or could have added? Just curious.
Yeah, absolutely. I mean, I think you always learn a ton building something, right? For sure. There's use cases you don't anticipate, or just macro technology trends that change things. I mean, we always took what we did super seriously in that sense, right? Because we know, look, if you've got 100 petabytes written like this in your organization, you need a really, really big motivation. The management has to be very big for you to rewrite it, right? So we knew that file format choices and so on would be slow evolving, right? By sort of the nature of what it does. So a lot of the work we did early on was to build extensibility into it, right? I think this was sort of a thing we got right. So the way I think about that is there are a set of Parquet requirements that are mandatory, right? For you to read and write it, you must do this, and if you don't, you can't understand the file format. Now, let's keep that as small as possible for compatibility, and then if we can layer optional metadata. So if you choose to use it, you can get more benefit or get more information, things like that. And that was the design we took from the beginning, and then I think that really helped us out. So there has been Parquet 2 and so on, where we've added things like new encodings or more metadata in
Bloom filters. Do you have Bloom filters?
Like Bloom filters, things like that. People have been adding things on how can you encrypt a particular column with additional metadata. All of those kind of things, but with the intent that backwards compatibility is paramount.
Right.
Now, did we make mistakes or things we wish we had done differently? Of course, right? I think I would say we made probably one of the most significant compatibility changes when we changed sort of metadata layout on the data pages. It's sort of an internal building block of Parquet. We I would say for sure didn't get that right the first time. So that's probably the most obvious one that comes to mind. And then I think overall, if I kind of rolled it back and how could we have pushed the project better and so on and so forth, I think there's probably a lot of lessons that we had at Cloudera, I'm sure you had rolling this out at Twitter, in terms of more like Parquet best practices. Right? How do you configure the things? We have a bunch of tuning parameters, of course, right? How do we sort of converge onto better out-of-box ones? That's probably the thing I think about the most is what I would have done differently.
I see.
Right, and even today, if you Google for like Parquet row group size and block size and all these kind of things, you're going to get lots of opinions from people on how to do it. And I think we could have done better as a sort of leading the project.
To guide people into how to best use Parquet and tune it.
And then in terms of V2, and I'll turn it over to Julien, bugs you have in the file format can be really painful.
So like file format evolved slowly because once you read in the file, right, it's going to stay there for a long time, right? And you need to be able to read it back.
Stable, it's got to be stable.
So we've been careful with trying, like, testing, not introducing bugs, but there have been a few things that we were underdefined in the spec. And so that's when there's room for interpretation. Well, of course, we had things that were implemented differently in, like, whether on the Impala side or the Java side of things. And then to deal with that, then you need to be able to read back those files, and therefore you have like a bunch of cases in the code to handle both cases, and that stays forever, right? So we work around those cases, but there's a couple who slip, right? And so that makes the thing more complicated because then everybody has to deal with that. Right? That when it's generated by this system, it looks slightly different. Right. And it's small things, but it does make things a little more complicated in some areas. I think we did a good job over time to standardize a lot on the types. Like data types in general in data processing are time-related types in particular. There are lots of opinions on what time is, and like I'm still don't wrap my head around the
nuances.
Timestamp without time zone is a terrible thing. I don't know. Like people will have different opinions on this. But so there's been some growing pains, but then I think eventually there's been a very good standardization. But it's like, when you have like Spark SQL, Impala, Presto, and Hive doing slightly different things, and you have to across all those project, like unify how time is understood. It's like there's some, I think Zoltan takes a lot of credit for his effort. Zoltan was working at Cloudera, did a lot of like, hey, how do we align those things?
Right. And talking about aligning it, it's quite fascinating to think that 10 years ago, cloud was not as such a big thing. In fact, people were still debating, is cloud really the way to go or not? But today it is. Is there, Nong, just from your point of view, anything different the Parquet needed to do to go from on-premises to becoming the standard for cloud? Or was it just smooth transition?
I think it was relatively smooth. And I think for a lot of the Hadoop ecosystem tools in general, it's pretty smooth. Right, so Hadoop has a file system abstraction, right? DFS versus HDFS that solves a lot of those kind of problems. But yeah, certainly the technology landscape has changed a lot from core storage technology in 10 years. I would say, certainly when we started the effort, and imagine probably Twitter as well, it was the original Hadoop architecture, meaning you have separation or co-located storage and compute. Right, you run your processing on the storage machines. We don't do that anymore. Right? S3 is completely elsewhere.
Desegregated compute and storage.
And I would say spinning disks was probably the dominant storage technology at the time, which have quite different performance trade-offs compared to, say, SSDs, and certainly very different from cloud storage, right, where it's sharded and all that kind of stuff. That's probably the main difference. I think if we ignored some of the HDFS requirements, we may have done something a little bit different, but it would be very minor. It's sort of in the periphery. How do you squeeze everything possible out of the design? And probably would have taken trade-offs in the wrong directions in other dimensions. So I don't think it had a huge impact on the project.
I have two specific things in mind of things. So one is originally in the description of the project in Apache, I had written like a columnar file format for Hadoop. So one of the big things I had to do is remove Hadoop from that statement because it's actually there's no real dependency on Hadoop except like this file system abstraction.
Right.
And I think second, when Netflix started using Parquet, so Netflix was a trailblazer in using Hadoop with the cloud, right? And they were using S3 as a storage. And Hadoop had this abstraction for S3, so you could read from S3 in the same way you would read from HDFS. But the difference is in the performance characteristics. So in S3, a seek on a file is a very expensive operation. And in Hadoop, well, when you seek to where, there's just some things in the code that was like sometimes we were already at the right point in the file, but we'd issue a seek anyway to get to the same point.
Yeah.
And in Hadoop, it was a no-op. It was just free. Right. And in S3, it would create a whole new request to the cloud service. And so all I did, I spent a day when this Netflix started using it, spent a day refactoring the code to remove those unnecessary seeks. Right. And that was it. And then that's, Netflix adopted it. I think that was a big stepping stone in the growth of Parquet, because then it was Twitter, Cloudera, Netflix, and the community started growing around it. And it just worked. It just worked in the cloud.
So talking about Netflix, that takes me to the modern world today. Probably the hottest thing that I'm surrounded with right now is the creation of table formats, which is now another level of abstraction, and it's just absolutely mind-boggling that now we have Apache Iceberg, Hoodie, Delta format, so I can now write my Spark, my SQL applications, and I can just move it from platform to platform as long as it's using the same table format. Any thoughts? And you were at Dremio, and Dremio is quite doing a lot of work on Iceberg and others to follow. Any thoughts on what's the progression from Parquet and how Parquet has enabled this new level of analytics through table formats?
We start with specifically about Iceberg, right? So the Ryan Blue, who was at Netflix at the time and started Iceberg there, had been a very long time one of the pillars of the Parquet project, one of the important PMC members on the project. And he was at Cloudera before, moved to Netflix. And so there are a lot of conversations in that community about having an abstraction on top, right? Because a file format is a file format, right? So you write a file, and once a file is written, you don't really have an abstraction on top of it, right? Like other people are going to read it, there's no abstraction there. So there was some discussion about table abstractions, and I think that's something Ryan had in the back of his mind for a long time, and it's he created Iceberg on top of it, like creating this, bringing the abstraction layer one level up, right? Having this notion of table and abstracting out partitions and so on, because before in the Hadoop world, you would write a partition and then you could never rewrite things or move things around because people were depending on just a file path, right? So it was a bit of a pain. And so a lot of it, I think, came from that same community, and Iceberg being on top of it. And I think on the Hoodie side, it's funny because Iceberg and Hoodie came from different side of the problem. Hoodie was looking more on the incremental inserting,
streaming,
like from streaming to batch, and Iceberg is kind of like this kind of snapshot thing. So it's more like atomicity and snapshot isolation semantics on top of batch processing. But they kind of course, those needs converge, right? And they start like in similar table abstraction, and Delta is following very similar patterns. And there's a need for it, right? And it's funny to see also not just like the open source world with Spark or Presto, but also like the big warehouse is also starting to understand those table abstractions, right?
That's great. And Nong, any thoughts on the table formats and why they're now becoming so popular? In fact, we are recording this episode in mid-October. Apache Iceberg has been in use now for a long time in production cases, but 1.0 was released only like 3 days ago. So this is how new this whole space is, but there is a 1.0 now. So Nong, over to you. Any thoughts on these table formats?
Yeah, so I think the need is clear, right? I mean, we need to keep building easier and better abstractions that give more capabilities. So I think this natural progression makes total sense to me, right? I don't, just for people listening, they're really complementary, right? It's not, I don't think of it as a table format replacing a file format. or vice versa. The file format enables you, it solved one set of problems, right?
Correct.
That was our goal for Parquet. Let's solve this set of problems, so then other people can build on top and just assume this part is solved for. Yeah, so I think the table format, if we think the overall talk track that we've been doing so far is how do we get the data lake, Hadoop-like technologies to have more traditional data warehousing benefits, right? How do we get the best of both worlds?
Right.
And file formats, better performance efficiency, that's one part, that's critical. Getting table abstraction so you can get better mutability of your tables and get some of those semantics back makes a little sense, all sort of towards that goal.
Right. So where do you see, so Parquet has been, sort of the spark of, this progression in the analytics space. What do you see next? Like any thoughts on, now we have table format, like what is Parquet's contribution that you think will happen over the next 3 to 5 years? Any, Nong, starting with you?
Parquet's, again, I think Parquet's contribution is that we solved a set of essential problems, right? Like in some ways, like a fundamental essential problem, in a way that's proven to be good enough for many, many, many people, right? And that's appealing because it means then you can just choose to build on top of it. You don't need to reinvent the wheel. You don't have to worry about a whole set of problems related to this, right? So if you had to come up with your new storage format, then you have to think about ingestion, writing, performance testing, all these kind of things that now we can say, okay, this part is good.
Correct.
Don't worry about this. Build something, build the next kind of thing. So I think as we look forward, I see much better compatibility in the ecosystem, in the analytics ecosystem, because of Parquet, right?
I see.
Some of the things we talked about earlier with bugs and incompatibilities, that takes time to sort out. And I think we're past that.
Right.
So today, if I'm a end customer, end user, I have really high confidence that if I query the data through Presto or Spark or whatever, I'm going to get the same thing, right? Like that part is solved and it's going to be fast and so on. And I think if we carry that forward over the next 3-5 years, this is the building block that hopefully everybody can just benefit from, right? If you want to build a new engine, like we were trying to do with Impala, I don't have to think about this problem anymore, and that's great, right? I can go focus on what I want to do next. And I think some of these other abstractions will let us get there, right? So we talked about table formats briefly. If that gets to the same spot, right, just solving this problem for the ecosystem, then you can imagine new applications, ETL tools, things like that can really fundamentally just depend on this and build more value on top.
That's great. Julien?
Yeah, so I was thinking when you were talking, there used to be the two silos, like people would either have data lakes, whether they use Hadoop or they use S3 or like cloud storage, and then they had warehouses. Right, and they kind of like, when we do big data and we kind of have slower and we need to store a lot of data, it's in there. And that same, friction I was talking about at Twitter with Vertica was really true with any kind of warehouse. And then you had like an import mechanism, you had to transform the data in a certain way, and then people could iterate and query it fast, right? But they may not have the same data, it would look different or something. So there was those two silos. And really, the Parquet format has become really a standard, like BigQuery, Redshift, Snowflake. They can all read external tables. So those two things, and now people, I think in marketing, people talk about the lakehouse, right?
Lakehouse,
which is bring the data lake and the warehouse together, and they can interact, right? So you remove a lot of that friction, right? And independently of what technologies you're using, whether it's Spark or Snowflake, SQL, or other things, they can interact, and it's much. You have less of silos, and you don't have people that don't have access to data because of the technologies they're using, or what like analysts versus engineers. This distinction doesn't come in the way of like understanding the data or accessing the data anymore.
So the way data lakes and data warehouses are starting to converge into lakehouse. Now, I want to ask you, what do you think of operational and analytical workload? Do you see them converging or not? Do you see them distinct?
Yeah, I probably take the point of view that they will be distinct.
I see.
Right. I think it's hard to build a system that optimizes for too many different things, and those are both really hard problems.
I see.
I think that's probably the history I've seen over time. Now, I do want to double down on what Julien said. There's a difference between distinct and siloed, right? So I think they should be probably distinct because they're really optimizing for different things on the compute side. But the ability to share stuff between them, right? To say ETL from one to the other or hydrate it or those kind of things, we should make that easy.
Right.
That's I think a good place for us to be.
Yeah.
And I think kind of things like Parquet help.
I've actually noticed something very interesting. Like some of the time series databases, like InfluxDB comes to my mind. They had their own log structured merge storage format, but when they went to 2.0, they moved to object stores, because I think that converging on the storage and the format and then having different use cases is the right way to go. Every technology we deal with is getting disrupted all the time. So do you see that there would be a disruption to Parquet, or on a more positive side, what is the future of Parquet?
Sure. Yeah. I mean, as we've been talking about, building, hardening, integrating a file format is a lot of work, and I think it's work that we've done with the community and so on. So I think there's probably a lot of reasons why I think it will stay for quite some time and not be replaced in that sense. I'm really excited about sort of the integrations that are happening in the ecosystem on top of Parquet that's helping drive it in a few different directions, right? So Apache Arrow is kind of I don't know how to think about it, but a sister project or something like that, which is really enabling integration into this ecosystem in a way that's much more, I'd say, developer friendly or something like that, right? It's a lot of work to say get Parquet to work with Spark, right? I wouldn't say that's kind of most developers would embark on that task, but some of the work that Arrow's done can open this up to a very broad set of ecosystems and drive those kind of things. And I'm sure as part of that, requirements will start to emerge. How do we make it? The things we can do to make it really, really better. So I think those are things that excite me.
I find Arrow to be a complete complement to Parquet. Just like Parquet has optimized storage to be highly performant on disk, with Arrow, I can do the same in memory. And once we have that, then there's no serialization, deserialization, and it's a very fast transfer. And then with Arrow Flight, you can then extend it to even client applications and sort of get over JDBC limitations. So that's a great point. Julien, what about you?
Yeah, so I think to that point, right? So Arrow kind of came out of the same community, right? So people in the Parquet community, there was a need for columnar in-memory representation, because in a lot of cases we would take this columnar representation and turn it into rows and feed them into a query engine.
Correct.
And there's this seminal MonetDB paper that talks about vectorization, how you do more efficient processing on top of columnar representation in memory. But you need a different format, because the trade-off to store and compress on disk at rest versus this in-memory representation that you're going to execute your query engine on need different trade-offs in storage and compression. So Arrow came and was like this low-cost transfer, in-memory representation that can be not only is efficient for executing your query on top, but it's also zero-cost transfer, right? There's no serialization, deserialization. The same representation can be transferred from memory to another machine. And it's over the past 5 years, it's really growing the ecosystem, right? And now BigQuery does understand Arrow, I think Snowflake as well. Yeah. And so just the result set can be written in Arrow, right? So when you use pandas, a popular Python library for transferring data, you can get your result set directly from BigQuery, for example, no transformation, and then process on it. So you remove a lot of the slow plumbing from converting from one format to the other. And the other interesting thing that is happening on top of Arrow is DuckDB. So it's kind of DuckDB is this parallel OLAP query engine, but on a single machine,
Right.
So we're going back. We moved from big servers to
decentralized,
shared nothing,
and now back to central,
and now back to the
single
DB
machine.
because the machine gets much bigger. There are a lot more CPUs. There are a lot more memory.
Correct.
And so this massively parallel engine runs on one machine. But again, the trade-off of network speeds versus RAM speed versus all that are different. So it works differently, but DuckDB is this very fast engine that can work on a big machine. And so people move back to, I have my dedicated thing, and it's all built on top of Arrow. So this ecosystem from Parquet to Arrow, fast transfer columnar to columnar, and then fast execution on top of it, and fast transfer from one machine. It enables a lot of things. And it's this very modularized transformation, right? There's a lot you can do when you're not forced in one vertical product anymore, right? There's kind of more of interoperability and using the best tool for the jobs and a lot of flexibility. So it's very exciting.
We track literally hundreds of active databases, and then DuckDB comes around. Yet another database, but it's refreshingly different, and doing OLAP on a single machine at massive scale using Parquet and Arrow as a format, that is quite amazing. And I know Jordan Tigani and some other people have gotten together to create this company called Mother Duck to create a commercial version.
I've heard of it.
I want to pivot to what are you doing now before we end this episode. So Nong, where are you, what problem are you trying to solve, and where are you now?
Sure. So I'm the founder and CEO of Okera. We started the business about 6.5 years ago. And I would say if you continue the overall trend that we've been talking about, it's how do we make this modern data analytics stack more suitable, more powerful for enterprises, and sort of looking at the whole set of things. So I think the problem that I identified, from my experience at Cloudera and Databricks and this ecosystem, is that problems around data security, data access management, having trust that people are accessing the right data, and being able to control all of this in an easy, scalable way. Right? How do I, I've got 100 petabytes and 10,000 users I want to give access to data to. How do I make sure I'm doing that correctly and responsibly and all of those kind of things? So that's what we've been up to. If I zoomed out a little bit, I think it's just adding more pieces to the puzzle, right? So Parquet is how do we unify the base layer storage across different tools and make that easy for people? We talked about table formats briefly. So how do we do this in a high level abstraction to get better SQL, say traditional data warehouse semantics, or
ACID.
However you want to define that, ACID. Okera, how do we think about that from a security governance?
So fine-grained access control.
Really making that easy.
Right.
How do we do that across the ecosystem? So that's kind of what we've been up to. I feel like Julien is working on similar kind of ideas in that spirit.
Well, yeah, so it's interesting, on my end, so, for many years I worked on building standard formats with Apache Parquet and then Apache Arrow, and understanding there's a missing thing for an efficient data format in the community, and how we make that happen in this collaborative aspect, in building it together. So I think after that, there was a glaring missing standard in the community. It's a standard for operational lineage, which is about understanding for all those things that are running. So Nong is looking at it from the access perspective, but there's also from the lineage perspective, you understand how data is transformed across your entire data ecosystem. So a few years ago, I started a company called Datakin, which was focused on the data observability, data reliability, make sure the data shows up on time and is correct. And the basis for that and making it happen is creating this open lineage standard, which is open telemetry but for data, right? And understanding, and same thing, right? Leveraging the community and reaching out to people like Nong, like Wes McKinney, like people in the Spark community to work together as what this standard would look like. and really keeping this philosophy, or it's not going to be owned by anything, right? It's not my format. It's really our format. It's open source. Yeah, but there's different flavors of open source, right?
You should have named this one after yourself.
It's too late. The name.
Change your name.
No,
Julien.
I'm calling myself lineage. No, thank you. And it's really enabling a whole bunch of use cases. So of course, we've been focusing on the data reliability use cases, making sure the delivery of correct data is fine, but there's a lot of governance aspect, either in the banking regulations or for privacy regulation, or people need lineage, they need to be able to prove things or understand, for privacy, you need to know where your user private data is flowing through your system and make sure it goes in the right place and make sure when people want it to be deleted, you can. And controlling that, so that lineage is really important to that. So the whole host of different use cases. Also, optimizing your costs is another aspect, because the cost of your job of producing this data set, but the value is always downstream from that, right? You need to connect the value you get from things from the cost to produce it. And so a lot of those things. And so, last year we joined forces with Astronomer. So bringing together the actual operations. Astronomer is the airflow company, like orchestration, making sure your job run. So there's two layers, right? Orchestration is about once your job's dependencies are met, it's going to run, and the resources are going to be available, and the scheduling will happen on time. And then data observability is the next layer. The thing that orchestration doesn't guarantee is that your logic is still working, like someone may have changed the schema and your SQL fails. It doesn't guarantee that it happens fast if you don't have a performant things. And it doesn't guarantee it's not going to run if your dependencies are never met, right? If something upstream is not running, then your transformation is not going to run either. So data observability is really about bringing the user in the picture at what they can fix, and helping them troubleshoot really quickly, find the root cause of the problem, tell me everything that has changed between the last time it worked and the first time it failed. And not just in my job, but everything upstream of it, right? Or doing impact analysis, like preventing issues. Like before I make that change, who is going to be impacted by it? So it's kind of all those things that this enables, and we've been working on. So it's kind of,
it's fascinating to see that this journey that started 10 years ago is continuing, but the end goal is always to meet business use case, right? To make businesses successful. And to do that, we need to be able to trust the data. We need to be able to do root cause analysis of data. We need to have highly performant, reliable. And so that is what, even though we are talking purely technology, but the beneficiaries of everything that you've done is the business. So on that note, thank you so much for all your contributions. It's been absolutely fascinating. Cannot wait to see how this technology evolves further. I think we're living in the golden era of data, and you guys have a huge role to play in that. Thank you.
Thank you.
Thank you, Sanjeev.